In this video, we will look at the concept of efficiency. So when we are transferring energy from one store into another, some of that energy will be transferred into an unwanted store. The efficiency of an energy transfer is determined by how much energy we are able to get into the useful store compared to how much energy we tried to put in the first place. So let's take a look at the equation. The efficiency of anything is the useful energy out divided by the total energy in. Now it's important to note here that we will never get an efficiency of more than 1. This is because the energy you get out of a system will never be greater than the energy that has been put into that system. You cannot get more out than you put in. That leads us back to the idea of conservation of energy. Energy cannot be created or destroyed, it can only be transferred from one energy store into another. So, efficiency as a number. Let's just imagine that we have the useful energy out is 90 joules and the total energy in is 120 joules, and so we will write the efficiency as 0.75. There are no units here. Just as we've talked about in previous videos, 5 divided by 5 is 1, 10 divided by 10 is 1, a billion divided by a billion is 1, A divided by A is 1. Well, we have energy divided by energy, so joules divided by joules is 1. So there are no units to this number. Next, we have efficiency as a percentage. If we want to call a percentage efficiency rather than just a number, what we will do is we will simply multiply our answer by 100%. So in this case, the efficiency 90 joules out, 120 joules in, we times that by 100% to give us that this particular transfer of energy is 75% efficient. So let's look at an example. A kettle is supplied with an energy of 2000 joules every second. The useful energy transferred to the internal thermal energy store of the water is 1800 joules every second. Calculate the efficiency. So, the useful energy out divided by the total energy in. The useful energy out is 1800, the total energy in is 2000, and that gives us an answer of 0.9 efficiency. The efficiency is 0.9. If we want to change that to a percentage, we simply times it by 100%, and we have that this particular transfer is 90% efficient. Next, a car transfers 45,000 joules of energy from its chemical potential energy store every second. 40,000 joules are wasted by being transferred to the internal energy store every second. Calculate the efficiency of the car. Now this time, we've not been given the amount of useful energy. We've been given the wasted energy. 40,000 joules are wasted. So how do we work out the useful energy? Well, the energy is equal to the total energy subtract the wasted energy. The total energy, that's the energy in, was 45,000. We subtract the wasted energy, which is 40,000. And so what we have is 45,000 minus 40,000. That will give us 5,000 joules out. So we have 5,000 joules of useful energy divided by 45,000 in total energy. That gives us an efficiency of 0.11. If we change that to a percentage, we have an 11% efficient engine. Finally, a human's muscles are around 25% efficient. A man pushes a trolley using 200 joules of his chemical potential energy store. Calculate the energy transferred to the kinetic energy store of the trolley. Now this time we've been given the efficiency. Now first of all, we'll convert it from 25% into a simple numerical number less than 1. 0.25 is the efficiency. So we have 0.25 equals the useful energy out divided by 200. Now, since the useful energy out has this unhelpful term underneath it, it is being divided by 200, we're going to use an inverse operation. We're going to multiply both sides by 200. Once we do that, 200 divided by 200 is 1, so we now have that the useful energy out equals 0.25 times by 200. This gives us an answer of 50 joules. The useful energy out is 50 joules.